so let's talk about how to find the molecular formula. So remember what the molecular formula was. So the molecular formula is a multiple of the empirical formula. Okay? So if I have the empirical formula, the molecular formula is just a multiple of it. So if it's a multiple of it, I need to know what is that multiplying factor. So I want to know, well, how many times more is it? So I want to find what we call the multiplying factor. So to find the multiplying factor, I'm going to take the molecular formula's mass, and divide that by the mass that I get from the empirical formula. So when I divide the molecular formula by the empirical formula, it's going to give me a number. And I always round to the wholest number. It should be pretty close. So you can round up or down depending on what it is. So once I get the n, I take the n and I times it by whatever the empirical formula is. And that gives me the molecular formula. Okay? And I could actually do the opposite. If I have the molecular formula, I could divide by the n to get the empirical formula. Okay? All right, so let's do a problem. Benzopyrene has a molar mass of 252 grams per mole and an empirical formula of C5H3. What is its molecular formula? So what is it asking me? It's asking me for the molecular formula. So when you see that it says molecular formula, the first thing you have to think about in your head is, ooh, I'm gonna have to find that multiplying factor. But let's just see what it says. So I want the molecular formula of this guy. And it tells me he has a molar mass of that. So I know that he has a molar mass of 252 grams per mole. And it told me the empirical formula was C5H3. And then it just gave me the masses of carbon and hydrogen. So since I want the molecular formula, I gotta think to myself and go, oh, I need that multiplying factor. So I need to find n. So how do we find n? N was the molecular formula mass divided by the empirical formula mass. So then we have to say, okay, well, where's those numbers? So the molecular formula mass, if I had the formula, I could just add it up. But if I had the formula, I wouldn't need to do the problem. So the molecular formula mass has to be something given to you in the problem. And so that's what this is. The molar mass of benzopyrene, this is the molecular formula. So they have to give me this number. So they have to give you that number in the problem, or you can't do it. The next one is the empirical formula mass. Well, they don't give me that, but they give me the empirical formula. So if I know the formula, I can calculate the mass, okay? Because I know there's 5 carbons, 3 hydrogens, and I know the mass of each one. So if I have 5 carbons, each of the carbon is 12.01. I have 3 hydrogens, all of those are 1.01. My empirical formula mass is going to be 63.08 grams per mole. So I just add it up, find the mass. And plug that in. When I do 252 divided by 63, that number comes out to be 4. Now you're not done. You just found the multiplying factor. The whole problem was the molecular formula. So now I have to take my multiplying factor, multiply it by the empirical formula. So 4 times C5H3. So 4 times 5 is 20. 4 times 3 is 12. And that gives me the molecular formula. Now, one of the things I want you to notice is your molecular formula can always be reduced. If you reduce the molecular formula, you get the empirical formula. So this step is kind of like step 5 of the empirical formula. But the difference with step 5 and the empirical formula is your final answer is not something that can be reduced. Because remember, empirical formulas cannot be reduced. They're the simplest ratios. Molecular formulas give me the exact numbers of how many of each element I have, where the empirical formula just tells me the ratio. So if it says to find the molecular formula, you need to find the multiplying factor and then multiply that by the empirical formula. All right, so that's the last part of chapter 4. So we'll end this lecture, and on the next lecture, when we start chapter 5, now that we know how to find these formulas, write these formulas, name them from the formula, or write the formula from the name, now we're going to start learning how to actually draw these in a 2D Lewis structure. So that's going to be the topic of our next chapter.